Let me start recording, and can you go ahead and introduce yourself?
Sure. Good morning, everyone. My name is Jerry Carr. I've been invited by Mr. Hoffkamp to come in and talk to this group. I greatly appreciate the platform, and I'll try to keep my initial comments brief, but I just want to tell y'all who I am, where I'm from, those kind of things. So I was originally born in Detroit, Michigan, born and raised out there, and it's one of those weird things. When I was growing up, I had no one in my circle really knew what to do career-wise with somebody that was good with math and science, except for one thing. They said you have to become an engineer. I have no idea what I had no idea at the time what engineering is or was, but I knew I had to go do it, and I kept trying to be as good in math and science as I could. Um, I got into a good school. I got to MIT when I was an undergrad, and then
1 second.
right,
When you say good school, you mean the best school for engineering.
it's it's wild, but there's more to that story though. You see, at the time, they weren't they were doing something called need-based financial assistance. So what that basically meant for a lot of people who look like me is we ran out of money and we had to work an extra 20 plus hours in order to sustain our undergrad education. And when you're already having to work 60 hours a week in order to keep up with the schooling and things like that, there was lots of times where you would have to go in, out, between semesters, working full time and then coming back. So I actually didn't wind up finishing there. I actually wound up saving money by finishing my degree at Georgia Tech, where they actually paid me to be there. So my first level of advice, honestly, is if you can identify anything you want to do with the way education costs are right now, find a good public school to do that initially, for your undergraduate education. And then grad school, hopefully you're doing something where they'll pay you to actually be a student. So just keep that in mind. If you can go ahead and do the MIT part in grad school, they actually pay you to do the work at that point, you know. But did the Georgia Tech thing, wound up getting my bachelor's degree. I just feel like I need to be honest with y'all. I got it at the age of 29 because that's how long it took me to kind of navigate through that system of financial difficulties. But it was good though. I mean, the type of jobs I was taking, I did everything from AmeriCorps to just working with various nonprofits. A lot of it through K through 12 education, trying to focus on, how to bring math and science to people who look like me, people who didn't look like me in the Boston area and in Atlanta, Georgia. So I'm still, that's still a huge part of what I do. And even as I went back to school as a graduate student to study plasma physics, I really wanted that doctorate just to go ahead and find a way to reach more people when it was all said and done. That and plasmas was fun. I got fortunate when I was at Georgia Tech to work with a national laboratory. The one I wound up with was Oak Ridge National Lab. That's down in Oak Ridge, Tennessee. A lot of people call that the home of the Manhattan Project. Some people think that's Los Alamos. I let them fight that out. But the reality is, great place. It was just an interesting experience, and that's how I got involved with linear accelerators and the work I did, which was plasmas, which is on the engine side, if you want to call it something, of the linear accelerator. Basically, it's the spot where you generate the ions that are necessary in order to fire it at a target. So we need a plasma to do that. I think it's a good idea for me to stop and say what a plasma is. Some people call that the fourth state of matter. Plasma physicists don't necessarily like that definition because there are plenty of places in space where you don't get four states of matter. But plasmas are basically what they're the most populous form of known matter that we understand in the universe, i.e., stars. If you think about it, if you heat up something from a solid to a liquid to a gas, you eventually get to that point where you have, um, ions basically in your substance in a way that can be
Can
controlled
I
by.
jump in?
What's up? Yeah, sorry about that.
What's an ion?
What's an ion? It's a great question. An ion, when we talk about particles, we talk about whether or not they're neutral or they have charge. If you know, I like using the atom example, where a lot of times you have just as many positive charges within that substance as you do negative. But as soon as you remove a negative ion or you add a negative ion, all of a sudden you have this imbalance. And that's what we call an ion, you know? So all of a sudden you have something that can be controlled by the fact that you have a negative charge or a positive charge. And that's how you get these batteries, you know, you get things like that where you actually have you take advantage of the fact there's a difference in charge. The particles that are opposite charges attract, you know, and that's so we use ions in that way. But you can also, there's also, you know, what goes on in stars is, you know, that's part of the process, but there's also magnetic fields that help control these things. That's the beauty of plasmas. Plasmas are, you know, we like using them here on Earth because they allow me to make machines like the one I'm using to talk to you right now. I'm using you know, a smartphone in order to make the chips that we need in order to get these smartphones. You know, a lot of advances actually were made on the plasma side in order to kind of control and make more, you know, make better chips that you can store more information on, you know. So, you know, we use plasma processing here on Earth. It's not just about stars. We use it for, you know, we talk about propulsion with plasmas. We do all kinds of things with plasmas. So that's why I study. Got to cut to the end of this right now. Currently, I am a physical scientist with another national lab called the National Energy Technology Laboratory. And, you know, that's why I'm stationed out here in Morgantown, West Virginia at the moment. It's been great. I actually serve as a project manager. So I actually manage a portfolio of scientific projects that are doing research on fossil energy projects. The thing about this lab is we're not just about making things, you know, we explore all kinds of stuff like how to make fossil energy processes more efficient. We also explore how to make them safer on the environment. Like, so my projects scan that entire spectrum. I even have a plasma project in that portfolio. But that's kind of background, and I still haven't left the social justice sphere just yet. I'm actually the president of the Morgantown Kingwood branch of the NAACP. So if y'all have any questions about any of this kind of stuff, please, I just want to throw it out on the table. I think the last thing I'll just say is that it's all right to be an unconventional student or a non-traditional student. That's what I am. You know, at the end of the day, when you get one of these PhDs, it kind of all resets the clock anyway on some level. So bottom line is, it's the most important thing is to figure out what it is you want to do and go for it. I started off wanting to be an engineer because that's what I was told to do. I fell in love with physics along that path. And that's how I wound up actually finishing my degree because I felt like that was the best match. And I had no idea what physicists did for a living. I didn't meet my first Black physicist until I was 28, all right, when I was looking at grad schools. So believe me, you know, there's only a few hundred of us, you know, throughout the world at the moment. You know, I'm feeling that we're probably in the, if I had to guess, maybe 600 range or something to that effect. But I'm happy to meet y'all, plain and simple, and love to hear any questions y'all have. So sorry I talked longer, but that's kind of how it went.
Yeah, that's okay. If there's like 600 physicists in the world, that makes you like one in how many million?
You mean like, well, when I say 600, I was talking about Black physicists, but
Right.
I think you mean like,
If there's, is it 7 billion people on the planet or 6?
oh, yeah, 7 billion. Oh gosh, yeah. So yeah.
Like
So
1 in 10 million. You're 1 in 10 million.
It's been a fun ride. I think that we're having a good time, and but at the same time though, the field recognizes that there's more work to be done. I mean, I'm only here because of a series of miracles in addition to hard work, you know, and that's unfortunately the state of our education system in this country. You know, a large portion of it is dependent upon what zip code you're born in, and that determines what happens with the rest of your life. So I had to buck a lot of those trends, and not everybody was able to do that, and that's unfortunate. we need to change, make these type of changes to our education system, have more conversations like this. Hopefully, people are meeting people like me a little bit at a younger age than when I met them. And hopefully, we continue to have these kind of conversations that can help guide people's careers. I mean, mentorship is a big, big deal. So I'm happy to reach out to any student through you, Mr. Hawkamp, to have continuous conversations, even if we don't finish this one today, in its entirety.
Yeah. Yeah. And if they ever have any questions for you, I'll definitely pass them along. If you have any questions for Dr. Jerry Carr Jr., please put them in the chat. Remember that you earn a couple of extra credit points when you do that. And any question works. I'll start asking a couple of questions because I'm interested in what you do. But more importantly, we're studying states of matter in class. So we're studying solids, liquids, and gases. So
Awesome.
Can you tell us, that's in with the 7th graders, can you tell us the difference between solid, liquids, and gases real quick?
Well, let's see. Honestly, it's about how fast the particles are moving in my mind, So, solids, we're talking about when you talk about solids, you're talking about particles that are that basically are just able to not have an average energy that's as high as, say, liquid or gas. And as you keep adding energy into the system, the particles want to move around a little bit more, so they don't want to just stay in one spot. They're never truly in one spot, so let me just say that as a caveat. But you can definitely see how when energy is being added, the things like to spread out, and that's how you eventually get to something like a liquid, and you keep adding more energy to it, you get a gas where those particles are all over the place. They literally fill the room.
Yeah, I have a student that says solids are tightly packed, liquids are close together, and gases move more freely. Is that correct?
Yeah, definitely.
That's excellent.
Yeah.
She's learning something in science class.
Well,
Somebody else wants to know when you want to retire, or if you want to retire, because we it's your career. How much do you love it?
Yeah. Give me 1 second before I answer that. I realize I have to turn on the power to my phone. Give me 1 second. So the last thing I wanted to do was make sure that my phone didn't, I didn't want my phone to die in the middle of this interview. So I apologize for just doing that. I thought that I had it all charged up, and but we're good to go there. So that's a very interesting question. I can't lie. Like, one of the things that attracted me to physicists is they seem to live a long time, and they seem to like what they do even into their 80s. Like, a lot of these cats, they just keep performing, and they just keep doing what they keep diving that field. And I see that a lot in the national lab circuit where I'm at, where people retire and they come back and they still continue to work and they still continue to do things. So I figure, if nothing else, that's an option to have, even if that's not what I wind up doing. I know that my mind is still very much focused on trying to find ways to bring STEM education, work through social justice, and all those kind of things. That's a big aspect. So depending upon where I am in life at those points in times, if I go that direction more than what I'm doing now, that's fine too. So we'll see. 2020 has taught me, if it hasn't taught me anything else, it's that I'm not good at predicting things of that level. So I'm gonna just be prepared, and I like having options rather than trying to just make solid plans. I hope that answered that question.
I think so. We have another question, but in order to ask it, I feel like I need to ask a first question. So what's the difference between a scientist and like you and an engineer?
Thank you for asking that question. That is a great question. And it took me a while to actually even get to it in my career. Engineers, they're great at figuring out how to do things. Because they're very much into the question of how. How do we make a better stapler? How do we make a better vehicle? How do we do these type of things? Physicists and scientists, they're more concerned about the question of why. And the question of why doesn't necessarily always lead to something that makes a better how, but it is a worthwhile exploration. So we ask ourselves things like, well, why did that behave that way? You know, why did this phenomenon do the opposite of what we anticipated? What kind of things can we expect if we do that? And that doesn't always lead to um, a better state, but for all you know, it could lead to a microwave. I mean, that's basically what um, wound up occurring. I mean, we tried to study one other thing in space, and we came across the invention of the microwave. And that's the kind of thing that happens from science all the time. There are other things that obviously are more targeted that come from science, but there's always value, in my opinion, in exploring the question of why, because you never know what you're going to get. You never know what you're going to get, and pretty much all of it can serve value, or provide value.
Someone wants to know if it is fun doing physics.
Let me think about this. The answer for me is yes. There are parts of it that are labor intensive, but um, I don't know. I think the best way of describing it is if you do something long enough, you get good at it, and that winds up just being one of those things you do in the background. People get scared when I talk about physics, but the reality is it's the complexity of that is I compare it to learning how to drive a car. I mean, there's no way in the world that people who drive cars, they think about it as maybe a simple task, but reality is it's completely complicated. So complicated. It's just that you got experience doing it. And so therefore, that's what makes people feel comfortable. And physics in my mind is the same kind of thing. You do need some help, some good teachers, you got to invest the time into it. But once you get good at it, it's hard to turn that part of your brain off. You wind up using it in almost all kinds of interactions. And what's interesting for me, and the reason why I probably chuckled when I heard that question, physicists wind up all over the place in the workforce. Some of us do direct science. Some of us wind up in the legal industry. Some of us, we're just all over the place. I encourage people to check out APS, the American Physical Society. Like, check out their website. People fill out questionnaires all the time as to like what they do with their careers as physicists. You can check that out and take a look at the pie chart that they have over there. But what I'll say is, a lot of scientists, I think we wind up spending maybe about 5 or 10% of our time actually doing physics. The remaining part of that time is actually spent, for me, for my example, leading projects. So that's people skills. That's finding ways to get things done, and also in project management skills. Trying to figure out what's the way to make sure that this thing gets delivered on time and on budget. A lot of scientists have to run into that no matter where they are, whether they're faculty members, scientists in national labs. You just don't get out of that. So having all those other skills outside science are essential to being one. And that's probably true with a lot of professions. Yeah.
And how long have you been a physicist?
That's one of those weird questions. Some people believe that if you ever thought about it, then you've probably been one your entire time on this planet, but a practicing physicist, even that's even hard to answer, because some people consider people with the bachelor's degree as the cutoff point where you can start saying that. Some people say you have to have the PhD, and I don't really care. I mean, I'm going to say that I've been in this for, wow, I haven't even thought about it that well. Let's just call it, let's throw out a number, let's say 15 years or so, But my PhD, I got it in 2013. So if you want to benchmark it that way, then we can go that way too,
And I have a chess player in my class. So do you play chess?
I like it. I'm not great. I mean, I can do a little bit, but I'm not gonna pretend I'm great. Actually, a game I do have fun with is actually Chinese chess, actually. So I love to play people with that too. I picked that up when I was in Boston working with a you know, just there was like over 120 some odd languages spoken in the neighborhood I was working in Dorchester, Massachusetts, and a group of Vietnamese kids helped me learn that game. So it was I'm still playing that to this day too. It was awesome.
Um,
Mhm.
how much money do physicists make?
All over the spectrum, all over the spectrum. Yeah, I've seen, and again, the APS website is actually good at showing kind of estimates. I don't remember the median range, but the good news is we don't have trouble getting jobs. You know, we might have trouble convincing people that we are useful for what it is that they do, just because they're unfamiliar with how we think, things of that nature. But the unemployment rate for a physicist is pretty low, you know, and that's actually a good thing. Um, I think I remember I can identify physicists if you're at a bachelor's level having jobs at say 40K, and even if you're staying at the bachelor level, you can still get into the 90 plus K range. It all depends on where you land and what skills you pick up along the way. I mean, there are people who are you get a bachelor's in physics and wind up getting masters in engineering. You know, so how do you count that? Um, um, but at the same time, though, I mean, scientists that wind up doing that, I mean, you could easily make six digits too, staying in the physics realm. It just all depends. Um, so yeah, I'm sorry to give such a weird range, but that's literally what you're going to probably find on that website. That range is huge, you know. But the big thing is you won't go hungry, you know.
Um, remember that if you have questions, please put them in. Oh, there's another one. Be putting them in chat, and otherwise, I'll be asking my questions because I've got lots.
Hmm.
If nobody told you to be an engineer, what would you have done with your life?
Man, that's tough. 'Cause at the time, I probably would have gotten it wrong even for even a longer period of time. Um, but I mean, I was fortunate. I mean, I was able to do right, to write and things like that. So, um, if I could stomach it, maybe I could have been a lawyer, but it just didn't mesh well with um, all my skills, I guess. I felt like I was good at being able to have discussions with people, negotiate things, even, do arguments and things of that nature, whatever is necessary. And that skill has helped me, and absolutely beneficial for my scientific career. Um, but I wanted that science piece too, so maybe that's what would have happened. I don't know. It's hard to answer that, but it would have had to have been something where math and science was involved, though, I think, just because um, I don't know. I really enjoy those subjects, you know.
And then this is a question I ask everybody that we talk to. So how has being black affected your career?
Mm, well, hard question to answer. Just because it's actually hard for me to separate myself like that. I mean, but there are straight up realities. I mean, one, um, I'm the first Black physicist to actually graduate from WVU with a PhD. That was 2013. You know, the institution has existed a long time, and it's 2013 when that happened. So it's if you can imagine what that's like to some degree, it's hard to even put that into words, but that's what you can start with that to some degree. You can start with the fact also that, like I said, didn't find my first Black physicist until to have even a sit down conversation with until I was 28, So for a while, I was just looking into going into something where I didn't necessarily see myself. Um, and, even after you meet one, it's not like I'm surrounded by them at that point. You're still trying to, navigate through that whole piece. So, um, there are just inherent challenges with being Black and sometimes being the first of something. And it wouldn't just be that, it'd be other things too, or being one of the few. All I can say to that is we know we're out there. It's just we got to find each other. Like there is organizations like the one I'm involved in, National Society of Black Physicists. There are other organizations out there that, National Society of Black Engineers. There's you got to find these groups and compare notes. I think that's probably the best way of going about dealing with those kind of things. And they do have, literature, studies, all kinds of stuff where they can, impart real knowledge to you that can help you out. So just gotta find things like that. Other than that, I mean, I would say that, I am a Black man. I'm about 6'2.5", 200, let's say just, about 250 pounds or something like that. The bottom line is people have a different expectation with me, when I take off my glasses and they see me walk in the room, then, sometimes when I am sitting down, I'm at a Zoom call and things of that nature. You do navigate through that sometimes. I've had some very interesting conversations with, staff at universities that I've worked with, that I actually was a university professor before I got this particular job. And, I've had weird conversations with police, just like every other Black person in this country, probably, so, but the reality is, you just keep fighting. You gotta find different ways to approach the fight, and find different outlets. And that's hopefully what I've tried to do and try to bring to my kids, those kinds, those kind of lessons. So I don't know. I have to think about it probably a little bit more if I want to give a better answer than that, but that's probably where I would start.
And I want to say thank you again for talking to us, because you are, that example that, like, 2013 it happened, And so now when I have a student that wants to go to WVU and become a physicist, they know that they can. You know what I'm saying?
Yeah, no, I appreciate that. I'm actually excited about the institution because I know that there's been, now there are some more coming into it. There have been challenges, so I'm not going to act like it's been the rosiest picture. And I think the challenges honestly go, I mean, there's still some challenges that institution is putting forth in front of those kids. And that's true with probably every university. I mean, WVU is not the only school that's looking for its first Black physicist right now, or you're just having its most, or just having one that just started that trend recently. So, but like you said, it has been done, and nothing else. If I know that somebody's going there and they want to reach out and talk to me, I'm there for them. We'll make it happen. Because that's all that matters to me, is that people accomplish their goals, and I want to do everything I can in order to help them get there. If they can, if the thought has come across their mind to try to do something like that, then we got to find a way to get everybody to the finish line. And that's true with bachelor's degrees, graduate degrees, whatever. We got to find a way to make sure that we overcome all these kind of numbers that impact retention and things like that.
We only got 5 minutes left, and we're starting to get a few more questions. What do you like about your job?
You think? You know what? The thing that has always attracted me to science is actually the people. I always love the subject matter, but you just run into some really interesting people when you're in this stuff. I've been fortunate to work with Nobel laureates. I've been fortunate to, work with
What's a Nobel
technicians.
laureate for people that
Like
don't know?
Nobel Prize. It's just like what they call themselves. If you win a Nobel Prize in science, you call yourself a Nobel laureate. That's just
And I guess I didn't ask specific enough. What's a Nobel Prize?
Nobel Prize, highest honor of achievement you can get basically in fields like in sciences, basically medicine. Um, and that's that angle. You can also get it, obviously for doing things like what Martin Luther King did, so peace prizes out there. But it's that that's basically what we're talking about. Is just trying to win that highest honor. So when I say I work with some of those cats, and it's, I'm talking about people, I guess, who made a significant discovery, in science that revolutionized the field. And, you talk with that, you talk with people who, you get the opportunity to talk to those people, you get the opportunity to talk with people who are, technicians, who are incredibly fascinating and intelligent. You get to talk to people all over the spectrum. And and they get to dialogue with you, and that sharing of ideas is just I'm excited about that. That and the fact that science is, I think, chief goal or objective that we're trying to achieve is to help better humanity's experience on this planet. At least that's the way I feel about it. That's the way I govern the way work I do. I think that we have to spend a lot of time as scientists understanding that it's got to serve a purpose. And sometimes you don't know exactly if you're always going to get something that's purposeful out of it. You still have to explore everything and anything. But I think when it's all said and done, we want to come back and we want to make sure that we're helping this planet out. And I think this work that I'm doing has definitely given me a chance to do that. So I would say those are probably the two things.
Another question that we have, what's the hardest obstacle you faced while being a physicist?
While being a physicist? Let me think. The challenge always grows. So, I'm sure that whatever I say now, there'll be a bigger challenge, next year, people sometimes talk about grad school being the most challenging thing, but you get out of that at some point and you run into the workforce and you pick up some new challenges. So, I mean, right now, the challenges I'm facing are organizational based. How do I make sure that, these projects are hitting their deadlines, achieving their goals? They're all over the place. How do you be a good steward for all these different things that are happening at the same time? So, that's where I'm at right now. But I also assume, I also consider it just as big a challenge of how do I get people interested and make sure they find out that this is a career path in the first place. I want people to know that this is something they can do with their time. And so I think that's almost just as big a challenge as the science itself. But the science itself needs people who are willing to take that challenge on. Otherwise, you don't get to sustain the darn thing. We need scientists everywhere, man. We need scientists in the government. We need scientists in politics. We need scientists all over the place. And even getting people to understand that that's part of what needs to happen once you get this kind of education. You still have to go ahead and find other ways to give. That could be one of my bigger challenges. But we don't have a year like 2020 without recognizing that we're falling short in those kind of endeavors. So, it's time to just be real about that. We need to invest as much time in that as we do wherever it is our current day job is, as far as I'm concerned.
It is time for us to finish this interview for today. We have a few more questions, though, so maybe we'll have to continue the conversation on another day, interview you or have a part two if you were willing. I really appreciate it. I learned a lot from you, and I'm sure our students learned a lot from you. Here at this school, we always say asante, which is Swahili for thank you, or asante sana, which is Swahili for thank you very much. So thank you so much for talking with us today.
Hey, thank you.